Our next speaker is Andrew Dux, and he'll be telling us about suppression of Lake Charr and Lake Pend Oreille.
Well, thank you very much. I'll admit it's a little bit of an interesting feeling being here along Lake Superior talking to a bunch of char enthusiasts about lake trout suppression. But I'll also note that it seems pretty appropriate too, just given that all the work that's been done within the native range of lake trout and the overharvest that's often occurred in their native range is really the very reason why we've been able to take on lake trout suppression as a management tool. So when we started working with folks in their native range, we quickly realized, geez, if these things can be overharvested, especially on a large water body like in the Great Lakes, certainly it has potential to work in a much smaller lake in Idaho. So what I'm going to try to do is summarize kind of how we got to suppression in Lake Pend Oreille, which is one of the two largest suppression programs along with Yellowstone Lake that's been taken on so far. Give you a little bit of that background and then go through some of the results that we've seen after now more than a decade of lake trout suppression. I do want to start by acknowledging my co-authors, Mike Hansen and Matt Coursey, along with just a whole host of people within our agency and outside our agency. This has been just a tremendously big project to put on the ground. We've also had tremendous funding support. As Dan mentioned, you've got to have staying power to do this, and we've had two fishery mitigation programs from Bonneville Power and Avista that have funded that, and commercial fishing expertise from Hickey Brothers. So just a lot of people have made this possible. Start by orienting you a little bit. Dan kind of, I think, oriented you to Idaho, and so now within Idaho, Lake Pend Oreille is in the northern portion of the state, just a little bit south of the Canadian border. It is the largest lake in the state, and so by Western standards, this is a big water body and a large-scale thing. Not quite as impressive to folks that are from the Great Lakes area, but a big water body by our standards. By anybody's standards, it's an exceptionally deep lake. In fact, the fifth deepest natural lake in the U.S., maximum depth about 350 meters. Historically, the fishery in Lake Pend Oreille was pretty simple, and the two native species that had angling interests were bull trout, which were the predator historically, and cutthroat trout, which were also native and popular with anglers, still present in this system. Dan mentioned a little bit about bull trout, although there are plenty of places in their range where they're struggling. Pend Oreille is one of the strongest populations in the western U.S. Now this fishery changed a lot in the 1930s. Kokanee were introduced upstream in Flathead Lake and eventually dispersed downstream. And once they hit Lake Pend Oreille, they flourished, and in a very short time period, the most popular sport fishery in the state of Idaho developed. Not only were folks interested in targeting kokanee, but kokanee had a dual role in that they were an abundant prey source for predators, which initially was just bull trout, but soon after the introduction of kokanee, Girard strain rainbow trout were also stocked in the lake. And so this is a strain of rainbow that's native to Kokanee Lake just north of us, co-evolved with kokanee, and when kokanee are abundant, these fish can reach tremendously large sizes. And so what happened was not only did we have a popular kokanee fishery, but a world-renowned trophy fishery quickly developed. So in the 1940s, what's still the world record bull trout was caught in Lake Pend Oreille, and then around that same time period, the former world record rainbow trout was caught. And so since that time, it's had this notoriety, and whenever we've been able to maintain high densities of kokanee in this lake, it continues to be able to produce these incredibly large bull trout and rainbow trout that are, as you can imagine, very popular. So this traditional fishery that really kind of centered and depended on kokanee really was in jeopardy by the late 1990s. It had other things that kind of came and went over the years that produced ups and downs in the population, but we were at risk of flat out losing kokanee because of a growing lake trout population. Interestingly, lake trout were stocked in 1925 by the U.S. Fish Commission, and they were in the lake just kind of in the background for all those decades. And until the 1990s, we never really even saw them show up in creel surveys. But as Dan described earlier, mysis were introduced in the system, and after a bit of a time lag, lake trout responded to that, and from 1999 to 2006, we saw exponential growth of lake trout in Lake Pend Oreille. This scenario had already played out in some of our other nearby waters like Priest Lake and Flathead Lake, so it wasn't hard to kind of look at those as examples and see, If lake trout were allowed to continue to grow and go unchecked, we would see collapse of kokanee and bull trout, which happened in each of those two water bodies within about a 10 to 15-year window. So we decided to move forward with a pretty aggressive management strategy, and this was after consulting with experts from the native range of lake trout. After getting that information and doing some initial research, we started forward with lake trout suppression. Had some key goals. First, obviously, was to reduce lake trout abundance, but more specifically, we wanted to see if we could drive abundance down by 90% from its peak in 2006, which would get it back to where it was in the 1990s before there were really any problems with lake trout predation. Obviously, we also wanted to be able to sustain the native bull trout population. It's been well documented that bull trout populations don't fare well in the presence of introduced lake trout. And obviously, we wanted to prevent what looked to be an inevitable collapse of kokanee in this lake and allow that to recover. And then by doing all this, be able to bring back that hugely popular recreational fishery that so many people value. So as far as the lake trout suppression program itself, we came at this sort of with two primary components. The first was to contract commercial fishing company, Hickey Brothers, that Dan mentioned. We really thought it was important to bring that commercial expertise to Idaho and the ability to run these commercial scale gears. Over the course of the suppression period, we've contracted them for about 30 weeks a year. And then the other thing we did was we enlisted the help of anglers. So we started an angler incentive program. We paid people $15 for every lake trout they harvested. So you catch a lake trout, you remove the head, you drop it in a freezer location around the lake, and we cut you a check for $15. So that, as you can imagine, motivated angler harvests tremendously. And it also gained public acceptance for this program because anglers were part of the solution. All this work began in 2006 following some initial research that was done, but removals began in 2006. And we were able to target really all size classes of fish in this population. With the Hickey Brothers crew, we were able to use gill nets, both small mesh and large mesh, to target juvenile and adult lake trout. We also were able to use trap nets that were effective for removing adult lake trout. And then the anglers were pretty effective at these sort of intermediate sized lake trout, along with some larger fish too. But with these multiple methods, we were able to put a lot of pressure on really all sizes of fish. So for the rest of the presentation today, I'm going to focus on some objectives that we laid out in terms of evaluating this program. We wanted to look at the response of lake trout, bull trout, and kokanee over the period of 2006 to 2016, so that's the first 11 years of suppression. We wanted to see how much did the lake trout population decline over that time. We wanted to revisit some of the modeling work that Mike did early in the program, and in fact, if I remember right, was presented at this symposium in Scotland. At that time, the projection was we'd see a 67% decline by 2015. So we wanted to check in on that. And then we also wanted to see how we were progressing toward that long-term management target of a 90% decline from peak abundance. We also wanted to take a look at lake trout demographics and just see, is that consistent with what you'd expect for 11 years of suppression? Typically in an exploited population, you might expect to see declining size and age structure, increased growth, mortality, those types of things. So we're going to look at a few of those metrics. Obviously, we want to just see how have bull trout responded. We're able to sustain a bull trout population. We're able to keep kokanee from collapsing. Even, again, back to that early modeling work, with high fishing mortality on lake trout, there was a high probability we might see kokanee collapse anyway. So we wanted to see what that ended up looking like. So I'm going to start moving through results now, but I want to start by just showing you the amount of fishing effort and harvest that occurred over this 11-year period. From the netting end of things, we used trap nets a lot in the first few years. They were pretty easy to get in the lake and start fishing. And at the time, we were still trying to learn how to best deploy gill nets and minimize bycatch and those types of things. So there's a lot of trap net effort early on, but quickly gill nets started to be the tool that we used the most, and we got the most effort out using gill nets. And in particular, in 2008, we used telemetry to identify 3 lake trout spawning sites in this lake. And so from that point forward, we were able to target all the large mesh gill netting towards adult lake trout at spawning sites over about a 5-week period in the fall. Soon after that, we identified what we call nursery areas, so some select areas in the lake where we see high densities of juvenile lake trout that we could effectively target with small mesh gill nets. And so for the other roughly 25 weeks of the year that we suppress, that's where that gill net effort goes. So we're kind of hitting the top and bottom end of the population with gill nets. So in terms of harvest, over this 11-year period, we've removed close to 200,000 lake trout. I do want to put that in perspective. In places where lake trout have been able to reach higher density, like Yellowstone Lake, this is a much taller order, and they'll remove well beyond 200,000 fish in a single year in the Yellowstone suppression effort, whereas we've removed that many in the entire time period. And it just speaks to our ability to get started in the early phase with a lot of fishing effort before the population really got going. I also want to point out early in the program that angling component was a really important mortality source. Fishing was good at the time. Anglers were getting paid to go do it, and they got after it. And we saw a lot of harvest from angling. And it was important because at that time, we were still trying to figure out the gill netting. We didn't know where the lake trout spawning sites were yet, and we were kind of learning how to do this. But eventually, after we learned that, then gill netting kind of took the places of angling as the primary source of mortality. But having these multiple methods, I think, has been important and allowed us to maximize the pressure that we put on this population. So the next thing we want to look at was mortality. And obviously, you'd expect that you start a suppression program and put more effort out there, you're going to see increased mortality. This just shows what that looks like. So this is our annual mortality broken out by the different removal techniques. As we increased effort in the program, we saw increasing mortality. Over the 11-year period, we averaged annual mortality around 31%. So that is a fair bit below the 50% threshold that Dan mentioned. And so with that kind of mortality, obviously the next question became, is that enough mortality to drive down abundance? And so we predicted, based on that early modeling work that Mike did, like I said, that we'd see about a 67% decline by 2015. We were able to generate estimates of abundance using a cohort analysis, using Pope's method from 1972. And this just shows, in particular, I want to draw your attention to this age 3 and older abundance trend. So we started out around 130,000, 140,000 fish, and that declined by 58% during the suppression period. So a little bit short of this prediction, but not too far off. And so we're kind of in the ballpark of what we expected might happen. So were we able to have an effect on recruitment? Do we see recruitment overfishing? We predicted we'd see a decrease in recruitment in response to reduced adult abundance. We looked at this again using that cohort analysis. On the left here, I have age 3 abundance. This is the age at which lake trout were first fully recruited to our gill nets. So we use this as an index to recruitment. And what you can see is over that time period, we saw about a 56% decline in age 3 abundance. On the right here, I have age 8+ abundance. That's the average age at 50% maturity. So this gives you a good idea of what the adult segment of the population is doing. And again, it declined at a very similar rate. So what we saw here was evidence of recruitment overfishing. So next thing we looked at was size structure. We predicted that most exploited populations, you would see size structure decline as mortality increased. We didn't really see that. It's pretty variable, but we suspect what's going on here is we just had such a low density population that it was really hard to have something here that would respond the way you might expect with a higher density population. Age structure wasn't much different. Again, we expected, in a typical situation, you would see declining age structure as mortality increased. And much like size structure, this just was pretty variable over the time period. And again, is I think a very good chance just a product of the low densities that we were dealing with. So growth rate. We predicted we'd see an increase in growth rate as abundance declines, in kind of that typical scenario. And again, a lot of variability here, but no real evidence that that occurred. So important to understand that when lake trout were getting established in Pend Oreille, we were seeing incredibly fast growth rates, approaching, as fast as you could see, or that you'd expect to see for the species. So there really wasn't a lot of opportunity for this population to respond with even faster growth. They were already cranking it at close to their biological potential, I think. So not a real surprise here. So I'm going to shift gears a little bit now over to bull trout. So we want to see how did bull trout respond to this. I mentioned earlier that bull trout and other systems have declined really rapidly in response to a growing lake trout population. So there certainly was potential for that to happen in Pend Oreille if we didn't have success with lake trout suppression. We predicted that we would see the bull trout population be sustained relative to the pre-suppression time period. So we just took a look at our red count data set. This has been a long time series in the Pend Oreille tributaries, and this just shows results from a model that Mike worked with us on that scales up from red counts to an estimate of abundance in this system. And you can see over a long time period here, dating back to the 1980s, there's been a lot of fluctuations in this population, but in general, it's been a pretty strong population. There's been a little bit of a decline here recently. Without going into too many details, I can let you know that that's mostly driven by other factors, an incredible drought year and some other water conditions that really influence red counts. And if I cheated and threw another data point on here for you, it would be much higher. So bottom line is we've seen bull trout sustained, which has been a great thing. And in addition, I didn't mention this, but bull trout are commonly something that we have to try to avoid in terms of incidental bycatch. So we've been able to target lake trout and avoid bull trout enough that we've been able to sustain this population. So, kokanee abundance. Obviously, the million-dollar question is, did kokanee collapse? There was this 65% probability that they would, even with a high level of fishing effort on lake trout. Fortunately, that didn't happen. We started suppression right in here. Population bottomed out in about 2008, but then very quickly we saw a strong response. Kokanee came roaring back, and back to or above levels that we saw in the early 1990s before lake trout became a problem. So this has been a great thing. There's a whole other chapter to this story. If you saw Matt Corsi's poster, there's some other things going on with mysids in this system that are playing into this, but certainly without effective lake trout suppression, it would not have been possible for this resurgence to have happened. So, in summary, we saw over this 11-year period of suppression, lake trout abundance declined by 58% for age 3 and older lake trout. That's pretty close to that predicted decline, and I think highlights the importance of doing some of the simulation work. It can be a really effective tool. We're still below that long-term target of a 90% decline, but we're starting to approach it, which means that we're going to have to start thinking a little bit about how we transition this program, and we'll talk more about that in a minute. We've seen evidence of recruitment overfishing to this project, and we didn't really see any evidence of density dependence. Didn't see a notable decline, and we were able to sustain bull trout over this 11-year period. We were able to avoid the collapse of the kokanee population, and in fact, we even were fortunate to see that rebound to a pretty high level. And so, in conclusion, on a local level, lake trout suppression has really proven so far to be a pretty effective tool for us to meet our management goals in Lake Pend Oreille. We've been able to reopen the Kokanee harvest fishery, return to trophy management of the rainbow trout population, and people have just returned at a very high level to fishing this lake, and it's been hugely popular with the public. On a broader scale, I think we've been able to show that suppressing lake trout in a large, deep lake outside their native range is achievable. There have been several attempts now to suppress lake trout in western U.S. lakes, but I think the experience we've had in Lake Pend Oreille certainly is the first example that on a large scale that you can suppress lake trout to meet management goals. So where do we go from here? Well, I think the next step is, like I said, trying to get to that 90% target that we've set forth for ourselves, and not only that, but see if we can get there and then reduce the amount of effort it takes to do this. What is it going to take to keep lake trout at a low density into the future, and can we do that at a much lower cost? Are there changes we can make to our program to do that? And so those are some of the very questions that Mike Hansen's going to address in the following presentation. And with that, I don't know if there's time for questions, but